Good morning. 안녕하세요. 일본에서 온 나카무라라고 합니다.
I am Nakamura from Japan. Thank you.
So I have a long history with Korean barrier packaging market. However, I cannot speak Korean language so very well, despite my face looks like Korean. So many times when I visit to new customer, I was talk to Korean actually. Anyway, today I will make a presentation about Kuraray's solution to sustainable package. This is my career history summary. So I have a very long career in EVAL resin product from 2008. And now I'm manager of EVAL resin sales department and supervise Korean and Japanese market. Let me introduce Kuraray company overview briefly. Kuraray was established in 1926, so now we have almost a 100-year history. We have over 10,000 employees in more than 30 countries. I also would like to emphasize that Kuraray has a lot of world #1 share products, around 60%. EVAL is one of them and already used a lot in Korea. This slide shows our products and how we approach to the sustainable issues. We have many products that contribute sustainability, EVAL plastic, that is a biodegradable barrier material, and carpet. With them, we believe we can approach all the issues of ours. In the right side, recycle, resource, reduce, and redesign. Today, I will make a presentation mainly about EVAL recyclable package. But if you are interested in other products and other parts, could you please contact us after the presentation? Next, first of all, I will talk about the brief introduction of EVAL resin itself and its business overview. EVAL is a copolymer of ethylene and vinyl alcohol. EVAL has hydroxy group, and each hydroxy group bonding and it improves gas barrier property. EVAL has high gas barrier property and used in many food packages to block oxygen to extend shelf life. Just 1 millimeter thickness of EVAL has same oxygen barrier as 10 meters of LDPE. And also, EVAL has ethylene polymer unit, and it is also recyclable in polyolefin package stream. So here is the summary of EVAL growth history. We start EVAL business in 1964. Now we are 6 years old. So it has growth together with social needs. Firstly, extending shelf life. It means change non-barrier package to barrier package. It's widely spread with transportation network growth and also supermarket stores growth. Next, better logistics, lightweight. We replaced glass jar of seasoning such as mayonnaise and ketchup to EVAL multi-layer bottles. We also replaced metal can and glass bottles, as you can see in the middle of this slide. And now, sustainable package, we replace many kind of aluminum foil to mono-material package. For example, toothpaste, tube, and snacks. So in addition, of course, EVAL is widely used in meat package film and cooked rice tray in Korea, like Heppan. This is a map to show EVA production site in the world. Currently, we have 3 plants in the world: US Houston, and Belgium Antwerp, and Japan Okayama. EVA resin has over 100,000 metric tons per year. However, Okayama factory is not big, and we import from US and Belgium to the Asian countries. Global balance territory by territory is not good at this moment. So then now we are going to have a new plant in Singapore and increase the capacity by 28,000 metric tons per year by 2026. The reason of this capacity increase is catch up sustainability demand, especially in Asia. Next, I will talk about the sustainable package of EVA. This is a summary of global recycling guidelines. For example, in Europe, Cflex and recyclers is relatively well known. Right side of the table will show some comparison of barrier materials for recycling status with polyolefin. Many guidelines said that EVA is compatible with polyolefin, such as polyethylene or polypropylene. EVA has a good compatibility with polyolefin because it can be contained about under 5% with weight percent. Sorry, here. On the other hand, other barrier material like PET, nylon, PVDC, and aluminum need test case by case or not compatible in these guidelines. One more recent big news is PPWR regulation in Europe. With this regulation, all of the packaged material will have to be 100% recyclable by 2030. So we expect the average increase its importance in the barrier material market. This is a summary of EVR policy in Asia countries. Korea, India, Vietnam, Philippines, and Thailand. So many countries started to think about or start or some regulation. So you can see a lot of countries in Asia proceed recyclable package regulation. So I don't explain this regulation detail today, but I mean, so it shows it is not only Europe and America's problem. Sustainability is very important. And this slide is Korean CFC target. So you may know this is CO2 emission reduction target set by the government in South Korea. According to the press release, it says Korean government targets 40% reduction of CO2 by 2030 from 2080 emission. EVA barrier package also can contribute to this CO2 reduction target. I will introduce some calculation result later. This is recycling package proposal for sustainable package from us. I will talk about 3 proposals today. First, aluminum laminated tube we call ABL replacement. It is replacement of body part of laminate tube. We replace inner barrier layer aluminum to EVA. Second, VMPET and aluminum foil packaging replacement. It is ultra high barrier package. For this application, we recommend metallized EVOH multi-layer film. First, making multi-layer film, and after that, vacuum metallizing on EVOH layer. Third, PVDC replacement. Actually, we have 4 targets on this slide, but so I will make presentation detail of these 3 parts. Okay, first is aluminum foil replacement. This is a packaging structure overview of current ABL. Sorry. This is a packaging structure overview of current ABL and EVOH PBL. Our basic concept is to replace aluminum foil in barrier layer with EVOH resin. Of course, aluminum has a very good barrier property, but if you compare the two structures as a tube, there is not much difference. In the middle, we show OTR numbers. 0.023 cc by tube and 0.05 25 cc by tube. You can see EVOH structure is almost same as ABL. Because laminate tube has HDPE monolayer shoulder part. Then some amount of O2, oxygen, enters through shoulder parts, and the result OTR is almost same. Also, it is important that many European brand owners already apply EVOH PBL, so it is already usable. Next, I will explain about CO2 reduction, CFP calculation. We compare two structures here. One is ABL, PE 100 micron, aluminum foil 15 micron, PE 100 micron structure. The other one is EVOH PBL, PE, EVOH, multilayer film, and PE. So we use picket system, packaging impact quick evaluation tool, and then this is a result. So in conclusion, EVOH PBL can reduce a lot of CO2. As a standard, we put CO2 emission of ABL structure as 100. First, the virgin EVOH PBL can reduce around 40% of CO2. Because a lot of CO2 is produced in aluminum production. Then, and the U can replace L to EVOH, then many CO2 emission is reduced. In addition, it is very important things. EVOH PBL is recyclable, so it can reduce additional 70% of CO2. So totally, EVOH PBL CO2 emission is about half of PBL. Then we think that EVOH PBL can contribute to Korean government target. Okay, next I will talk about aluminum and VMPET replacement, ultra high barrier replacement. This is a structure proposal with EVOH. The basic concept is metallized on EVOH layer. First, our customer make multi-layer film by co-extrusion, PP tie layer EVOH. After that, they put very, very thin aluminum vaporized layer on EVOH layer. Its thickness is angstrom order, then it is not influenced to recyclability. And after making multi-layer VM EVOH polyolefin film, after that, dry laminate with other layer. For printing layer, they use BOPP and polyolefin sealant layer. And then it can have higher barrier property, very, very high gas barrier. We propose this ultra high barrier film to replace aluminum, mainly pouch packages. This is a comparison table of each structure. Metallized EVOH is green part. You can see metallized EVOH structure has very close barrier property to aluminum foil structure. Not only OTR, but also WBTR is very high. Of course, regarding barrier, EVOH structure is much better than VMPET. And also, only our proposal structure is compatible for monolayer polyolefin. This is the storage test result. We tested EVOH structure with powder milk. First, we test OTR. In conclusion, there is no significant difference between aluminum foil and metallized EVOH, and the point of 150 storage days. This is WBTR comparison. As you can see, metallized EVOH has almost same WBTR property as aluminum foil at the point of 150 storage days, as same as OTR. And we also calculate CO2 emission in each package. We compared aluminum foil, VMPET, and metallized EVOH structures packages. As same as ABL replacement, we use picket system. And the next slide is the result. Same as ABL, EVOH structure can reduce the CO2 emission. As a virgin package, EVOH and PET have almost same emission, but EVOH package can be recycled, so EVOH is better. However, in addition, it is very important things again. So EVAL structure is recyclable, so it can reduce additional 11% of CO2. So totally, vacuum metallized EVOH structure CO2 emission is about half other structure. In short, metallized EVOH emission is around 40% of aluminum foil package. Okay, lastly, we explain about PVDC replacement for mainly raw meat products. So you may have an image that PVDC is used a lot in raw meat packaging film, and EVA is not so. However, according to our in-house research, EVOH is already used in many raw meat package market in the world. Regarding beef, regardless beef or pork, wholesale or retail, and bone-in or less. In this graph, A means that the market share of EVOH have high. Actually, US, Asia, and Europe, we have more or less share about raw meat package, especially relatively high share in bone-in market. So I want to emphasize again that EVOH can be usable in not only pork, but also beef package in Korea as well. This slide is comparison with PVDC structure with our special grade EVOH, SC grade. Kuraray has a special SC grade to replace PVDC, which has good barrier property and sustainability, and also shrinkability. So could you please contact us if you are interested in this special grade. Again, the most important thing is EVOH structure is recyclable. PVDC has good barrier property, we know, but EVOH packaging also has its good barrier property and also recyclable. It is very important things for us. This is a storage test of 75 days sample picture. Left side is PVDC and right side is EVOH, EVAL. You can see EVA SC grade almost has same storage property in case of beef. Okay, this is a conclusion. First, EVA is very good material for polyolefin recycle stream. Second, using EVA can reduce CO2 emission, which can contribute to the Korean government reduction target. Therefore, regarding barrier material, EVA is the best solution to sustainable barrier packaging. Thank you.